Hi folks, we're going to take a look at number 17 from page 75, and it's a little question about using properties of limits. Okay, so what they give us is a couple of conditions. They tell us that the value of f at some unknown number a is 0, and they tell us that the derivative of the function at that same number a is equal to 6, and they want us to find this limit here. Okay, so let's see how we can figure that out. So when you look at this expression, this certainly looks like the expression for the derivative of the function at a. Okay, has some components of that. So I'm also given the value of that limit, since f prime at a is defined as a limit. So let's write that out. Let's write the information that they give us. So they're telling us that the limit as h approaches 0 of f at a plus h minus f at a over h, this limit not only exists, but it's equal to 6. Okay, so this is our starting point. Now, they give us a little more information. They actually tell us that f at a is equal to 0, so I can simplify this a little. So I can write the limit as h approaches 0 of f at a plus h, okay, minus 0 over h, and that's still equal to 6. Okay, but the limit I'm looking for has this 2h in the denominator. Okay, so I somehow need to get a 2h in that denominator. Okay, and this is where we're going to get to using the limit definition, the limit properties. So one of our limit properties, okay, I'll write that on the side, says that the limit as, whatever x approaches a of some constant times a function is equal to that constant times the limit of that function. Okay, and this works in either direction. So it allows me to take a constant out of a limit, but it also allows me to put a constant into the limit if I think of it in the other direction. Okay, so that's my goal. So I'm going to multiply both sides of the equation by 1/2. Oh, times 1/2. Okay. And now I'm going to bring this 1/2 into the limit. But this is where we have to be careful, because there's a condition on being able to use this property. This property only is guaranteed to work if this limit of the function actually exists. But since the derivative exists, we know this limit exists, so that's why we're allowed to use the property. So we're allowed to write that as limit as h approaches 0 of f at a plus h, and bring the 1/2 in, so that gives me my 2h in the denominator. Okay, and we're allowed to do that since the limit exists. Okay, and we know the limit exists since the derivative exists. Okay. Okay, which is f prime at a. Okay, since this derivative is defined as that limit. Okay, and so now we have our answer. It's equal to 3, okay, which I don't think should be a big surprise. However, we have to make sure that when we're applying one of these limit properties, that we're justifying that we're allowed to, that it satisfies the condition given.